Hello everyone, this is Heading Tian. This video we're learning 4.3, graphs of tangent and cotangent function. Before we are learning the function's graph, let's see the definition of vertical asymptotes. We have learned the vertical asymptotes in college algebra, the rational functions area. So if I have a vertical asymptotes, for example, this red dashed line is vertical asymptotes. That must be a vertical line. So my function will getting close to this vertical asymptotes, maybe from this way or this way. So my graph getting close to it, but never touch it. So for example, this one, we have the x value is 2. So as the x approaches 2, y's value approaches positive infinity or negative infinity. So this represents the vertical asymptotes. Okay, so x equals 2. That's the vertical asymptotes. All right, let's see the graph of tangent function. If I have a table, I can list the value of the x, the value of the tangent, and then, for example, I have negative pi and negative 3 pi over 4 and negative half pi, and then find all the tangent value. And also we have a lot of positive angles and find tangent value. I'm graphing an image like this. So this is a graph of the tangent x. You see the vertical dashed lines. These are vertical asymptotes. Cool. These dashed lines, they are vertical asymptotes. My graph will getting close to it, but never touch them. The tangent is an odd function. So tangent negative x equals negative tangent x. Domain of the tangent x is not equal to 2n plus 1 times half pi. How can we find the domain? Let's use the unit circle. Help us to find the domain. On the unit circle, there is a point on the y-axis here. So for example, I say this one is 0, 1. And for that point, that's a tangent half pi. For tangent equals y over x. So y is 1, x is 0. This is undefined. How about from here, I do rotation, pi rotation. I got a point here. So this point is 3 pi over 2. And what is the point here? 0, negative 1. And tangent equals negative 1 over 0, undefined again. So from here, I do another pi rotation. I will always get the point here. So my x will never equals the point here's angle. They are pi over 2 and plus pi plus 1 pi, 2 pi, 3 pi, so plus n pi. Let's say n is positive negative 1, 2, 3. So all the integers, positive or negative integers. So the domain of the function is x is not equal to half pi plus n pi. But why they gave us this? Because they do some modification. All right, so from half pi and n pi, let's factor out the half pi. So factor out the half pi, and what is left over? Where is n pi? Where is half pi from n pi? There's no n pi. Half pi here. So let's make a half pi. Half pi plus 2n pi over 2. So this is n pi, but I'm enlarge the top and bottom. And then we have half pi here, half pi here. This is pull out the factor, GCF, 1 plus 2n. Oh, that's how we get to the domain. They move the 2n plus 1 in front and move the half pi to the end. So this is the domain of the function. And what is the range of the function? From the graph, you can tell the domain, the range, all the y's value from negative infinity to infinity. The period of the tangent is pi. That means after pi, they have the same pattern. They have the same graph. Okay. For the tangent, so one full cycle, we will only look at this. From here, negative pi over 2 to positive pi over 2. So most of the time, we will only focus on the function between half pi to negative half pi to half pi. And there are three important key points. And let's graph the key points here. First line is first row is the angle x. Second row is tangent x. So the points, special points, they are negative half pi. This is the vertical asymptotes. And the end point, we say that's half pi. That's also vertical asymptotes. Between them, the three important key points, they are negative pi over 4, 0, pi over 4. And find the tangent negative pi over 4, negative 1. And tangent 0, 0. Tangent pi over 4 is positive 1. So please remember this table. We will use this a lot later. Okay, what is the vertical asymptotes? Oh, vertical asymptotes is a vertical line. My graph will never touch it. Okay, that is the right side of the domain. So the x will never equal to this vertical asymptotes value, but my graph will get close, very close to the vertical asymptotes. All right, let's see. If the x approaches on the left side of pi over 2, so look at the symbol that represents approaches the x value on the left of the pi over 2. So on the left of the pi over 2, okay, it's here. You see, all the way going to the infinity. So the y's value approaches infinity, or tangent x approaches infinity. And if the x approaches on the right side of the pi over 2, okay, on the right side of the pi over 2, that is the y's value approaches negative infinity, or tangent x approaches negative infinity. All right, let's look at the cotangent. Cotangent is an decreasing function. Oh, tangent is an increasing function. Decreasing function from the left to right, I'm going down. My graph is going down. Cotangent is an odd function. So if I have, it's same like a tangent. Cotangent negative x equals negative cotangent x. That means that if I do the rotation 180 degrees, I will get the same graph. The domain x is not equal to n pi. What's the meaning of this? Okay, we can also use the unit circle help us to find the domain of the cotangent. So if I have a point here on the unit circle, this is 1, 0. If I have point here on the unit circle, this one is -1, 0. What is the tangent of the point here? The angle is 0. And why I'm saying tangent? Cotangent, sorry. Cotangent 0. So cotangent equals x over y. So what is the x for the first point? 1. And y is 0. And how about the second point here? So cotangent, this is pi. This is also y or x over y. So is -1 over 0. They are all undefined. So any point or any angle, the terminal side on the x-axis, so that's undefined. Okay, so based on the first point, do a rotation half pi, pi, another pi, another pi, another pi. Okay, so my x is not equal to n times pi. For 0 pi, 1 pi, 2 pi, -1, 2, 3, 4 pi. I'm having my terminal side on the x-axis, make the cotangent undefined. So that's the reason we have the domain of the cotangent is not equal to n pi. How about the range? From the graph, you can tell the range is -infinity to infinity. The period is pi. So we have the vertical asymptotes here. vertical asymptotes here. Between two vertical asymptotes, that's one full cycle. That is period pi. And vertical asymptotes, x equals n pi. Here is a review. Cotangent x is a reciprocal of tangent. Also, cotangent equals cosine over sine. And the 5 key points or 3 key points of the cotangent. So x cotangent x. So the beginning and the end point, they are vertical asymptotes. They are 0, half pi. Oh, sorry, pi. And I can use vertical dash line represent the vertical asymptotes. And the 3 new key points between them, they are pi over 4, 0, 3 pi over 4. And the cotangent value, they are 1, 0, -1. So remember these key points, 3 key points, and the 2 vertical asymptotes. Okay, let's see. This is a conclusion. I will not repeat it. So you can pause the video and look at the conclusion. Tangent and cotangent do not have amplitude like cosine and sine. So here is a guideline for sketching tangent and cotangent function. So if I want to graph y equals a times tangent bx minus c plus d, or y equals a times cotangent bx minus c after it plus d with the b greater than 0. Okay, if I want to graph this, it's very similar like the form of the sine and cosine. First one, I need to determine the period. So for the period of tangent and cotangent, it is pi over b. And locate 2 adjacent vertical asymptotes. Solve the following equation for the x. Okay, so look at the parentheses. What do we have? We have bx minus c. So put the bx minus c between negative half pi and positive half pi. Why I need to list my one full cycle between these 2 numbers? Because I know the graph of the sine for the basic tangent function is from half pi, negative half pi and half pi, and there's an increasing graph. Okay. And so the initial point, that's vertical asymptotes, and the end point also vertical asymptotes. So by solving the x, I can find the new vertical asymptotes for one period. And for the cotangent, what is the graph of cotangent? Cotangent is a decreasing function from 0 to pi. This is half pi. Decreasing like this. So the first point is 0, last point is pi. By solving the x, I can find the new vertical asymptotes for one period. And sketch 2 vertical asymptotes found from step 1. Step 3, divide the vertical formed by vertical asymptotes in 4 equal parts. Oh, so remember the table I mentioned? Okay, so that's why I divide the full cycle into 4 equal parts. For example, this is the tangent function. I don't know tangent what, very complex tangent function. I found the new full cycle. From the first step, I found the 2 vertical asymptotes here and here. So my graph will be like this, right? But I need to have some key points. So I have first point, last point, and in the middle, I need these 3 key points. So these 3 key points, the x value you see, 1, 2, 3, divides the one full cycle into 4 equal parts. 1, 2, 3, 4. Okay, that's the reason the step 3 divide the interval form the vertical asymptotes into 4 equal parts. And the number 4 evaluates the function for the first quarter point, middle point, and third quarter point using x value found in step 3. Okay, find the value of these 3 points. Number 5, find their y's value and use the smooth curve connect them. So I can graph my tangent or cotangent function. Okay, let's see the first one. Graph tangent 2x. What is the first step? I want to find the period. Period of tangent and cotangent, they are pi over b. Oh, it changed. It's not 2 pi over b. Pi over b, b is 2. So pi over 2, oh, half pi. And then remember, what is 5 key points for the tangent? Let's put it here. For regular tangent, x and tangent x. So we have 3 key points between the vertical asymptotes. They are, so the vertical asymptotes is negative half pi is vertical asymptotes. Then first key point for the tangent, it is negative pi over 4, 0, pi over 4. The value is negative 1, 0, positive 1. So based on the tangent, we do some transformations. Okay, what are these? So let's find the new full cycle for the tangent 2x. We put the 2x between negative half pi and half pi. So for the x divided by 2, 3 parts. So x is greater than negative pi over 4 and less than pi over 4. I need to divide. This is not a very good image, but it's okay. So this is negative pi over 4. And this is negative pi over 4. I need to divide it into the 4 equal parts. So this is the middle. I need to divide it here, divided by here. So I can use my initial point plus 1/4 of the 1/4 cycle or 1 period. So 1/4 times the period is 1/4 times pi over 2 is pi over 8. Okay, that means I can draw a table x and tangent 2x. So the first key point is negative pi over 4. Last key point is pi over 4. Okay, so the second point is based on the pi over 4 plus 1/4 of the period is negative pi over 4 plus pi over 8. This is negative pi over 8. And then negative pi over 8 plus pi over 8 is 0. Plus pi over 8 is pi over 8. And plus another pi over 8 is pi over 4. And then what is the tangent value? So is there any y value changing? No, I didn't see the y's value is changing. So y keep the same. If the y is changing, we have something in front changed and after it changed. So nothing changed for the y. So y keep the same. Vertical asymptotes, negative 1, 0, 1. Let's plot the point. Vertical asymptotes. Vertical asymptotes. And the 3 new key points, they are negative 1. Oh, sorry. Negative pi over 8, negative 1. Y's value is negative 1, 0, and here, pi over 8, 1. So I need to follow the graph of the tangent. Okay. It's hard to graph it. I feel this point is like a straight line. Okay. So this is a graph of the tangent function. In your homework, you have multiple tries. You don't need to graph it, but you need to choose which one is the correct function. All right, let's see. Next one is also the tangent function. Let's find the new full cycle first. So now we have 1/2 x. Oh, so let's find the period first. So period p equals pi over b. What is a b? 1/2. So flip the bottom. I'm having 2 pi. Okay, we have a big period. And then we need to find one full cycle. 1/2 x is between, for the tangent, so it's between negative 1/2 pi and 1/2 pi. All right, so multiply by 2, all of them. I'm having negative pi and x and pi. Oh, that means the two ends, they are vertical asymptotes. Oh, they are vertical asymptotes. I need to find another 3 points between negative pi and pi. So find the y's value. So I draw a table, x and negative 3 times tangent 1/2 x. So the first and last, they are vertical asymptotes, negative pi, pi. In the middle, we have 3 key points. And they are, we need to find what is 1/4 of the period. 1/4 times 2 pi is 1/2 pi. Okay, based on the negative pi, we add 1/2 pi. Well, I have 1/4. So we are having negative 1/2 pi. And add a 1/2 pi, 0. Add a 1/2 pi is 1/2 pi. So what is the y's value? Is the y changing? Yes, it is. Yes, because in front of the y, we have negative 3. So based on the y's value, I need to multiply by 3 to not change the vertical asymptotes. So we have negative 1 times negative 3 is positive 3. 0 times negative 3, 0. 1 times negative 3, negative 3. Oh, that's a reflection along the x-axis. So let's find the negative 1/2 pi, 3. Okay, second point is 0, at y equals 0. Next point is negative 3. So we are having my graph look like this. It's not very good looking. So even we have the transformation, we cannot change the shape of the function's graph. Okay. So assume this is the beautiful tangent graph and getting close to the vertical asymptotes. So we graphed them. All right, let's see what is the next. Oh, it's about cotangent. So before we move to the cotangent, what are the 3 key points for the cotangent? So let's put the table here. This is x, this is cotangent x. So the first and last point, they are x value, they are the vertical asymptotes. They are 0, pi, vertical asymptotes. And here, the 3 key points, they are pi over 4, 1/2 pi, and the 3 pi over 4. Okay, the y's value is 1, 0, negative 1. Okay, based on this one, we will do the transformation. First, let's find the period. Period is pi over b. So we're having pi over 2, or 1/2 pi. And then the one full cycle, 2x, is bounced between 0 and pi. Solve for the x between 0 and 1/2 pi. When I'm having my new table, x 1/2 cotangent 2x. The first point is 0, last point is 1/2 pi. And the 3 key points. How to find the 3 key points? Based on the 0, add 1/4 of the period. That's 1/4 of pi over 2. That's pi over 8. So that's pi over 8, pi over 4, and add a pi over 8 is 3 pi over 8. So what is the y's value? What is the changing for the y? In front of the cotangent, we have 1/2. Oh, all the y's value becomes 1/2 of the before. So first and the last one, they are vertical asymptotes. 1/2 of 1 is 1/2. 0 times 1/2, 0. -1 times 1/2 is -1/2. So let's find the points. So first one is the vertical asymptotes, and this is also vertical asymptotes. And I will find the pi over 4 first because it's in the middle of 0 and pi over 2. This is pi over 4. This is pi over 8. And so, for example, okay, let's say this point is 3 pi over 8. So I got to the x value. What is the y's value? Okay, 1/2 here, 0 and 1/2, -1/2 is here. Okay, and then use the smooth curve, connect them. The point must go across the graph will go across the points. Okay, this is a function of cotangent. How about next one? What is 2 plus tangent x? Based on the tangent, we have the vertically shifting, move up to unit. So if I'm doing the multiple choice, I don't need to find my my key points. So what should I do? This is a very simple one. So for the tangent, I know that's the graph. The vertical asymptotes, they are -1/2 pi and +1/2 pi. And it will have graph like this. But if I'm moving up, 2 units, so before the table of tangent, so for example, this is -1/2 pi and -pi over 4, 0 pi over 4, and 1/2 pi vertical asymptotes, and tangent x, they are the y's value, they are -1, 0, 1. So based on this one, add all the y's value by 2. So -1 plus 2 is +1. So first key point is +1. And 0 plus 2 here. And 1 plus 2, 3. Okay, I'm having my graph like this. They are not straight line, they are smooth curve. It's not that good looking, but anyway, you must know that. So the graph looks like this. Okay. All right, let's see next 2 examples. So they looks very complex. It has more different transformations together. So how to graph it? First, I need to find what is the period of the function, the p. P equals pi over b. B is the constant in front of the x, that is 1. So the p equals pi. And what is the new period or starting point and end point for one period? Is I put the x minus pi over 4 between 0 and pi, because this is the cotangent. So starting point is 0, end point is pi. And so for the x is between pi over 4 and 5 pi over 4. Okay, I found the vertical asymptotes. Where is pi over 4? It's between 1/2 pi. So this is vertical asymptotes. And the 5 pi over 4, and maybe it's about here. Okay, so let's find the chart. So x, and this is -2 minus cotangent x minus pi over 4. Okay, so if you do not like the form like this, you can rearrange the order, because we have learned that we'd like to have y equals a times cotangent. This is cotangent b x minus c plus d. So they move the d in front. That means I can rearrange it. So I'm having y equals negative cotangent b, x minus pi over 4 minus 2. So you can identify what is the ABCD. Okay, let's continue to fill out the blank. So y equals, too much things, negative cotangent x minus pi over 4 out of the minus 2. So the initial x value is pi over 4, that's vertical asymptotes. We have 3 middle points. Last point is 5 pi over 4. And I need to find 1/4 of the pi, of the p period is pi over 4. So the second, the x value is pi over 2, and then continue to add pi over 4, 3 pi over 4, and the pi, 5 pi over 4. What is the y's value? So the y's value is based on what is transformation. We have reflection, that means all the y's value multiplied by -1 reflect along the x-axis, and -2. -2, that means next step, -2. So how to fill out the number here? So use the y's value of the cotangent table. So I need to move on to see the cotangent table, but you can also list it here. So for the x and the cotangent, and in the middle, the 3 angle, they are pi over 4, half pi, 3 pi over 4, and we have 1, 0, -1. Okay, what do we have? So we have 1, 0, -1. So the first transformation is 1. So do this transformation times -1 plus -2. This is -3. Next one is 0 times -1 minus 2, -2. And next one is -1 times -1. Then -2. So we have 1 minus 2 is -1. So we got the 3 points here. Okay, let's plot the point. Okay, -3. And oh, I didn't graph it. So this is the first point. And second point is here, 3 pi over 4 and pi here. So second key point, y's value is -2. Find -2. Okay, here. And when the x equals pi, we have -1. Okay, -1 here. Okay, follow the graph of the cotangent. So we have increasing function. So this is the new function of y equals -2 minus cotangent x minus pi over 4. All right, let's see the last one. What is the combination? And still this is cotangent. That means I can use this value here. So I don't need to graph a new, make a new chart. Okay, let's see. First step, let's find the period. Period equals pi over b. What is b? 1. So 1 period is pi. And how about 1 full cycle? So x plus pi over 4 is between, this is cotangent, between 0 and pi. So solve the x is between -pi over 4 to 3 pi over 4. Okay, I found the 1 full cycle, -pi over 4. So this is -pi over 4 and 3 pi over 4. This is 3 pi over 4. And we need to draw a new table. So this is x, and this is y's value, cotangent x plus pi over 4 plus 2. Okay. First key point is, oh, not 0, because we have the horizontal shifting, x plus pi over 4. Move to the left, pi over 4 units. So the first key point is negative pi over 4. Last key point is 3 pi over 4. Based on the first key point, let's add 1/4 of the p. 1/4 of the p is pi over 4. So the second x value is 0, and then add pi over 4, add pi over 4. Okay, we found them. So fill out the blank. Fill blanks. So what is the y's value for the x equals 0? Okay, I will go back to see the table here. So where I move my cursor here. Oh, this 0. 1, 0, negative 1. So what is the y's changing? Oh, we only have a plus 2 here. That's for the y part. For the y part only has the plus 2. So all the y's value move up to unit based on the 1, 0, negative 1. I need to plus 2. So 1 plus 2. I have 3. And then we have 0 plus 2. 2. 1. Oh, sorry. Negative 1 plus 2. Positive 1. So let's find the new key points. The 0, 3. 0, 3. And pi over 4, 2. Pi over 4, 2. This is pi over 4. That's interesting happen. I'm not sure why I have a 1 pi over 4 here, another pi over 4 here. So I should have pi over 2, because add a pi over 2, pi over 4 to the pi over 4. I'm having pi over 2. So the second key point is here. Oh, sorry. The third key point is here, is pi over 2. This is pi over 4. Okay, let's move on to see what is the y's value for the x equals pi over 2. 1. Let's use this one. Okay, so I have three key points. Connect them with smooth line. This is a graph of the cotangent x plus pi over 4 plus 2. All right, we have done for the 4.3. If you have any question, please let me know. Have a good day. See you next video.